Bismillahirrahmanirrahim. Today's our topic is matrices and determinants. First of all, I will give you introduction about matrices. Matrices is the plural form of a matrix. Now, what is a matrix? We will understand what is a matrix in this topic. Matrix is an ordered way to represent information. Especially the information is in the form of numbers or that may be in the form of functions. Sometimes even we may represent information in the form of alphabets also. But the most common way is to express numbers and functions in an ordered way. What type of ordered way? Rectangular arrangement of those numbers and functions. If they are put in parentheses, then we call such a representation as a matrix. First of all, I will move towards this mathematical tool. We know we have many mathematical tools such as graphs, such as integrals, such as differentiation, just like we have logarithms. They have different purposes in mathematics or in other fields. Similarly, we have a mathematical tool, we call that as a matrix. That matrix has its own purposes. Where it is applied, its applications are very vast. These matrices are applied in many fields. First of all, mathematicians have applied this matrix algebra in solving simple linear equations. Those simple linear equations by means of matrices, they were solved in an easy manner. After that, the same algebra were applied in banking purposes, in computers, in spreadsheet programming, in cryptography, in many more areas. I will point out here only this point. In science field, for example, we have quantum mechanics. That quantum mechanics deals with atoms and molecules, their structural features, their motions, their electronic arrangements. For that, we have quantum mechanics. That quantum mechanics is also developed in the form of mechanics. We call that as matrix mechanics. That was formulated by scientists Werner Heisenberg, Max Born, Jordan in 1925. Similarly, quantum mechanics we call also as wave mechanics. That is in the form of Schrodinger equation becomes the basis of that. So even the highest level, that means quantum mechanics in today's technology is in the form of a matrix. So a very good potential tool in the hands of a mathematician, or even in various fields in the hands of different experts. This mathematical tool is a compact way to represent information in an ordered way. Let us first of all, we will explain this point, what is a matrix. So taking, for example, in my hand there are two markers. I will put the information in this way. This number 2 is placed within these brackets. If denoted by, for example, this capital letter, I will say this is a matrix. Or afterwards, I have two markers and one ink bottle. I will keep that information in this way or keep that information in this way. 2, 1. Then this is also matrix, this is also matrix. For example, this one as B matrix and this one as C matrix. Similarly, if I have many more things, I could put them in this rectangular arrangement. Then this rectangular arrangement, which consists of rows and columns, that we call a matrix. This is the information. For example, these are two markers and this is an ink bottle. So information kept in this fashion we call as a matrix. So this information is, it may be either numbers or it may be functions, but mostly we have to restrict ourselves towards real numbers and real functions. Sometimes even we may represent these alphabets even in the form of this rectangular arrangement. Then this is also a matrix. If, for example, this is denoted by D, then this representation, this information put in this way is also a matrix. So matrix means an ordered way in the sense rectangular arrangement of numbers and functions put in parentheses in this way such that representation consists of rows and columns. Then that formulation we call as a matrix. This matrix is denoted by generally these capital letters. These entries within this matrix, they are called as elements of the matrix. In general, we would represent this matrix in this way: A11, A12, A13, dash dash, then A1n. This means this is the first row and this is the nth column. There are now within this matrix n columns. Secondly, I will write this A21, A22, A23, and so on, reaching to this point A2n. So this is the second row, and this one as nth column. In a similar way, I will reach to this point AM1, AM2, this one as AM3. Finally, I will write this AMN. So this AMN means it is the element which is present in mth row and nth column. This matrix is now composed of m rows and n columns. So there are m rows and n columns. M rows and n columns. The number of rows and columns, we call that as order of matrix. That is simply written in this way: m cross n, or m into n. This represents the order of a matrix. So I mean to say this matrix, if denoted by A, it is composed of m rows. These are the rows, these are m in number, and these are the columns. So composed of n columns and n rows, we call this as order of the matrix. Similarly, if anyone will say me, what is the order of this matrix? D. I can explain this. There are 2 rows and 2 columns. So its order is 2 into 2. Similarly, order of this matrix, 1 row and 2 columns. Similarly, the order of this matrix, 2 rows and 1 column. After that, this one, only one number means 1 row and 1 column. In general, we can represent this matrix in this way: A is equal to, that is equal to Aij. That means this Aij is an element which is at the position of ith row and jth column. So giving values to I and j, we can obtain the information. For example, if I have to represent this matrix, Aij is equal to, this is an element, this is equal to A21. That means it is an element which is present in a matrix at row number 2, column number 1st. So this is an element which is present in row number 2 and column number 1st. So we will simply noting down these I and j values, we can find the position of the entries, position of the elements within a matrix. Hope that you have understood the idea of a matrix.